And we are graphing polar coordinates. Chapter 9, Worksheet 1. This is Miss Oshier.
And Miss LaHart.
And here we go.
If you didn't have enough fun with graph and trig, this will be a lot funner. More fun. A lot more fun.
Okay. So we have the polar coordinate system. Now your whole world's about to change.
Woo!
Okay? Rather than having an X and Y axis like you're used to, you now have a polar coordinate system where you have a polar axis, you have something called a pole, and you have different degrees and radii on this. So you don't graph like an XY, you graph a radius and an angle.
Mm-hmm.
So all of your coordinates will look are theta.
Mm-hmm.
Okay.
Radius, angle.
So your radius is here, and your angle, as we just said, would be here.
Okay.
Okay. Boom, 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 boom. Radius, just showing you all the different things. Radius, angles,
Right.
etc. Okay. So a point on the polar plane is in the form r comma theta.
Mm-hmm.
Look at that.
Ooh, it's so stretchy.
R is the directed distance from the pole. Directed meaning we'll tell you a positive or negative distance to go.
Mm-hmm.
It can be plus or minus, see?
Mm-hmm.
Okay. And then theta is the directed angle.
Mm-hmm.
Same thing, positive, negative, etc.
And you're probably like, oh my God, I don't get it. Hold on, just watch one. Ready? Here we go.
Here we go.
4 pi over 3. So look at the diagram coming in. Look at that. You're used to that, okay? How long did we spend in, the circle, unit circle?
Notice I skipped 15 and 75, but they're there.
Yeah, they're there.
Okay.
So 4 pi over 3. So pi over 3, remember 180 divided by 3 is 60. All right. So
60 is right there.
And where is 4?
Right there. Because you go 1, 2, 3, 4 radii to get there.
So it's a point.
That's it.
That's all there is to it.
Boom.
Okay?
Next one.
Ooh.
5 pi over 6. That's 150. So we need to, again, find our coordinates, or degrees on it. You should be fine with this from the unit circle. So that's 150, but it says -8.
Okay.
So if I go 2, 4, 6, 8, 10, because 8 doesn't fit on there, I need to go the negative direction because I'm going -8 from this 150. So -8 is there.
Okay, so that's a little different,
A little
but
tricky.
not too bad. Okay, if it's positive, it's where it is. If it's negative, you shoot it across.
And if you're like, oh, well, how am I supposed to know what angle this is? Well, think about it. Remember all of those angles that we used in
Reference
unit
angles?
circle, all of our reference angles. Thank you. The word wasn't coming out of my brain.
That's not a
180
struggle.
minus 150 is 30, so 360 minus 30 is 330.
Mm-hmm.
That's how it all works, people.
There you go. 4 pi over 3.
240. Don't die on me.
Throat, verbal. Gah, bubble. I'm like, 4 pi over 3 is 240. Positive 7 is positive 7. Oh, that's in a half point.
That's okay. You can handle it.
Are you sure?
You guys got it.
No, no.
All right. Oh, negative. Okay, so let's just think here. That negative pi over 4 is -45. So if I think about it, that just means start at 0 and go -45, which is 315. From here, I'm going to 10. Again, 2, 4, 6, 8, 10. There's
And that's the
my
positive
radius.
distance.
Bam. Just a reminder. That's what I was using.
Okay. Ooh, boy.
Okay, so -3, 0. Well, 0 is on the horizontal axis, the polar axis, and then you go -3 radii. So you go in the opposite direction.
And there's your point. All right.
-5 on pi over 2.
Pi over 2 is 90, and then -5 would mean I'd shoot it across. Ooh, sound effects.
There you go.
Yeah.
And here I'm obviously going by ones. 1, 2, 3, 4, 5.
You probably labeled the point too, right? F, you put a little F near it?
Yes.
Okay.
If I was doing them all like on more than one,
Okay, gotcha.
which you're going to do in your packet.
Oh, yeah. So label your points.
Okay, so graphing polar equations. These are really not that bad, guys. Okay, r equals 2. Well, where would the radius be 2? Right on that circle.
And that's it?
That's it.
Look at that.
So again, where would your theta be? Pi over 6? Right there.
Because 180 divided by 6 is 30. So
And remember,
that whole line.
Yep, because depending on the directed distance of the radius we told you, you could be going one of two ways.
Well, that's not that bad.
That's it, everybody. Have a great day. We'll see you in class.
I love